In this video, we're going to discuss combustion of a furnace. In particular, we're going to discuss combustion for a gas furnace. What we have here is an 80% efficiency furnace, and it has a draft motor, draft blower, a gas valve, the combustion chamber, the gas manifold, the gas burners, and the orifices for each burner. Well, we're going to see how basically this system operates. We know that the gas valve will allow the gas pressure, the inlet gas pressure, to drop down from about 7 inches, and sometimes it'll be higher, down to 3.5 inches on the outlet of the gas valve. This is a combination gas valve, and it has a built-in regulator and a solenoid to control the gas flow. So it will regulate the pressure down to 3.5 inches through this manifold pressure. It will create at the orifices 3.5 inches, and that gas will be injected into the burner. This burner is basically a Venturi type burner, where you can see the zoom in a little bit so you could probably see it a little bit better. The construction of this burner, it starts out very large at the opening, and it will reduce down to cause a restriction, which will cause any restriction in airflow will cause the velocity to increase. So as the pressure increases, the speed of the air will increase and cause to drag air to mix with the fuel. So this, at the nozzle, is a small opening in the orifice that under pressure will shoot a stream in, and it will help drag the air around it, which is stagnant, to move along with it and cause it to mix with the fuel at the right proper velocity and combination of air and fuel. As it travels inside of the burner assembly, it will mix with the fuel and air, and as it reaches the outlet of the burner, it will ignite from a igniter located here. I'll bring it in a little bit so we can see it better, maybe. That igniter, well, it won't focus, but you can see the igniter. It has a ceramic on it. It gets extremely hot enough to ignite the fuel, which is natural gas. And it has what we call, as the fuel's mixing, we call that primary air. So it's pulling air to mix with the fuel to cause it to burn on the outlet of the burner. Not the inlet. It's mixing inside of the burner with air and fuel, which we call primary air. As it leaves the burner, it will be ignited, but it also needs additional amounts of air, what we call secondary air. So it will use air around the flame itself to cause the flame to burn better by burning and using additional air or oxygen to help it to achieve proper burn ratio with the air. So we're going to start it up and see how this works and take a look at the sequence of operation for this 80% efficiency furnace. We're going to flip the switch on and see what happens as it, first thing, draft motor starts, goes through a purge cycle to purge out any gas that possibly could be inside of the combustion chamber. And after about 30 seconds, the igniter will start to glow. It would prove that is energized. Then after that, the gas valve will energize to ignite the fuel. As long as it's a flame, and there is a flame sensor, which is located on the opposite side of the igniter. Igniter is here, but a sensor is actually in the flame to prove that there is a flame there. If not, it will de-energize the burner circuit to keep it from sending raw gas inside the combustion chamber. That could be very dangerous if it continued to send gas through. Now we see complete combustion using primary air mixing with the fuel. If you notice, I'm moving the pin around the side of where it's mixing. You can see that it's not burning completely because I'm stopping some of the mixture. But as it mixes inside of the combustion chamber, inside of the burner rather, it will ignite on the outside, and then it will use additional air, what we call secondary air, to help it burn completely. So complete combustion when there's the proper fuel and air mixture.